The last time we met, we talked about transactions. We talked about what transactions were, that they are the unit of work when you're talking about database programming. We talked about why they are necessary, right? We also defined the properties that every transaction might have, the acid properties of transactions, atomicity, all or nothing, consistency. All your changes must move a particular database from one state of consistency to another state of consistency. All the constraints must have to be met. The real life situation you are trying to mirror must always be true at any particular point in time. Isolation, your transaction must not be visible to another transaction so that no transaction comes in the way of another transaction. You don't want to be modifying data and somebody else is deleting that particular data. So we said all transaction must be isolated, and the isolation is the fence that kind of keeps one transaction from another. And we talk about the durability. So that's the acid property of transactions. And we said this is all necessary so that you can guarantee data integrity in your database. So we talked about the types of modes that you can have. We talked about auto commit, we talked about explicit and then implicit, and you must know the difference between an auto commit transaction, which is where you do not see any begin transaction or any end transaction. It's implicit. Or no, don't let me say it's implicit. It's automatic. All right. Now, every data modification you do when you don't see the begin and end transactions, that is called an auto commit transaction. But then when we now talk about an explicit transaction, that means that you either write the begin transaction. Did I say end transaction for auto commit? There is no end transaction. I don't know if that's what I said, but if that's what I said, there is no end transaction. There's only begin transaction, a commit or a rollback. Okay, I don't know if I had said end transaction. If that's what I said, please scratch that out. So I'll go over it again. Auto commit, there is an unseen begin transaction, there is an unseen commit transaction, or a rollback transaction. It's automatic. All the statements will be treated as a transaction. All the data modification statements will be treated as a transaction. Now you come to the explicit transaction, where you have a begin transaction that you see. You have either written it or somebody that wrote the program that you are managing or that you are trying to modify wrote that begin transaction. Either way, you would see a begin transaction. All right, that makes it an explicit transaction. All right, and then if everything goes on successfully after the begin transaction, then you get a commit transaction. All right, and at the point where it's committed, it becomes a fixed part of your database. If any error occurs, you can roll back the transaction. All right, that's an explicit transaction. You're explicitly starting the transaction, and we give an example of you taking control from the database server. You're taking control of how the transaction would work. Okay, so if you begin a transaction, you must make sure you commit it or you roll it back. Else, you risk holding on to resources that other people are expecting to use. Then we come to the implicit transaction, and we said for an implicit transaction, you don't see a begin transaction. Okay, this happens when you set a session flag. There's a session control. It's a session. It is a session property. You have to set that session property to either on or off. By default, it's in the off position. So it's like a switch. So if you want to use implicit transaction, you have to set, right, that session setting. You have to set it to on. All right. So if you set implicit underscore transaction, if you set it to on, that means that you are going to use an implicit transaction for that session, and you will not need to start a transaction. A transaction will be started for you, so you don't have to write, or you would not see a begin transaction. However, you would have to either commit the transaction or you would have to roll back the transaction. So you would have to write you would have to write out a commit transaction statement, right, if it's successful, or roll back transaction statement if it is not, if it encounters an error and it's not successful. All right. So if you set the implicit underscore transaction to on, you are using an implicit transaction. If you set it to off, then you are either using an auto commit transaction, or if you write out a begin transaction, that makes that session an explicit transaction. Okay, so just understand that you might be asked a question. Set implicit underscore transaction is set to off. What type of transaction is that setting using? That can be a question. All right. I think I've asked someone that question in an interview before. I asked, do you know the different types of transaction modes that you have? They rightly said the different types of transaction mode. And I said, talk to me about implicit transaction. And then they mentioned the setting implicit underscore transaction. So I said, if you set implicit underscore transaction, if it's set to off, then what transaction mode are you operating on? All right. The answer to that question is 1. It could either be an auto commit transaction if there are unseen begin transaction statement, or if there is a seen begin transaction. That means that if everybody can see a begin transaction statement, then that makes it an explicit transaction. Okay, and that is why implicit underscore transaction is defaulted to off. Okay, so any question? Okay, so those are the transaction modes. The final one is the batch scope transaction, but we are not going to be using multiple active result sets, so there's no need to talk about them now. But those are the transaction modes that we discussed last week. Then we discussed the statements that we have in the how can you write out transaction statements, or how can you make sure that the statements that you are writing, the logic you are writing, is in an explicit transaction, right? We talked about the begin tran. Whenever I say begin tran, it's the same thing as begin transaction. All right, so we talked about begin transaction. We talked about everything it does. We talked about the commit transaction, everything commit transaction does. We talked about the rollback transaction. So you know that the begin transaction starts a new transaction. It increases the count of @tran count. All right, we talked about commit transaction. Commit transaction marks the end of a successful implicit or explicit transaction. Okay, and we said the way it works on @tran count depends on if there is an already available transaction, there's an active transaction. So commit transaction just decreases at trunk count by 1. Okay, so if you have at trunk count already at 1, it decreases it to 0. There is no active transaction going on. Now if at trunk count is greater than 1, it decreases it by 1, and that means that there is still an active transaction going on. And you know what it means when you have an active transaction going on. We demonstrated that you are holding on to resources that other people are using. Your database management system, the databases you are working on, are multi-user databases, right? That is why you don't want to hold on to a resource. You don't want to lock a resource down for longer than necessary. And then we talked about the rollback transaction, which cancels any transaction, right, where you have maybe an error or something went wrong. A rollback would always cancel that transaction up till the begin transaction that is associated with. All right, so we talked about all this last week, and we went through a very small demo where we saw how a transaction or transaction statements work. So we are going to be picking up from there and still talking about transactions. We're going to talk about the session option, exact abort. All right, so now just like implicit underscore transaction that you saw, there are so many session options, right? So just like the implicit underscore transaction, just like the identity insert, there are so many other options that you can set during a session, right? And one of those, when we talk about transaction, is what we call the exact abort. All right, now what the exact abort does is that it controls the behavior of runtime errors in a transaction, right? Now you know what runtime errors are. All those errors that occur between compiling and executing your code. All right, remember the types of error. You can have a syntax error, you can have a runtime error. We are saying that the exact abort, the exact abort option is also a switch, right? It could be on or off. The exact abort option controls the behavior of runtime errors in a transaction, right? It's defaulted to off. So exact abort in any session, if you don't touch it at all, if you don't specify it, exact abort is off by default. But if you want to use exact abort, that means that you have to set it to on, right? So you can set exact abort equals on, right? It's the same way you did for set implicit transaction. You can set exact abort to on or off. All right, now we said the default is off, so it's do nothing. If you don't mess with it, it doesn't do anything. You do your work the normal way you've always done it. Now if you want to use exact abort, that means you have to set it to on. All right, and so when it's on, any statement that cause an error will be automatically rolled back. Okay, so if you start a transaction, if you set exact abort to on, and then you start a transaction, and you are writing your logic, and when the logic is being executed, you have a runtime error. Exact abort being on for that session will roll back any statement that causes an error. After doing that, it stops the execution of any batch that is remaining. So the rest of the batch will be stopped. So not only does it roll back the statement causing the error, it will stop any batch, any remaining part of the batch from executing. All right. Now, the best way to control runtime errors, like we said, is to use a try-catch block. All right, the reason for that is that exact abort is off by default. All right, so you don't have this situation if you don't turn it on. You don't have that functionality if you don't turn exact abort on. And that is why, because it's always off, if you are going to handle an error or if you are anticipating an error, just go ahead and use a try-catch block. Okay, so any question? Because we are going to go to demonstrate everything we've been learning about transactions. But before we demonstrate that, does anybody have a question? All right, please give me 1 minute, just 1 quick minute. All right, so let's go to our demonstration. Where did that one go? Okay. All right. So, like we said, first let's look at transactions generally. Okay? We've been saying that everything we've been doing so far has been done under the auto commit transaction mode. So just reflect back to everything we've been doing, right? When you are modifying data, you update, insert, delete, you've not been writing, there have been an unseen begin transaction. So everything has been happening under the context of an auto commit transaction. So we know that already. Now let's look at a situation where we have an auto commit transaction. All right, remember what an auto commit transaction is. You have to specifically tell the session that you want to use an implicit, right? Sorry, I'm getting myself mixed up here. First, an auto commit transaction, right? When you run in auto commit mode, your statement, without issuing a begin transaction or a commit transaction, your statement will be treated as a transaction. Remember what a transaction is. Everything has to, one, succeed together or fail together. That's the A in the ACID properties. So for anything to qualify as a transaction, it must have that ACID property. So if you have the ACID properties of transaction at the back of your mind, you'll be able to understand what is going on with all these transaction modes. So the first thing we are talking about is the auto commit mode. Okay, we said in the auto commit mode, you don't write a begin transaction, you don't write a commit transaction, you don't write a rollback transaction. It's unseen. Okay, so if that is the case, if we create a table and the table has one column which is an integer and has a primary key, the primary key on that table is that single column called C. If we insert into the table, right, and we said that an auto commit transaction, or we said that all the manipulation that you do in your database is done as a transaction, even when you did not specify one. So that means that if we run this statement, we are saying that everything in this statement would have to be a transaction. That's what we are saying. So we are saying that this statement must all succeed together or they must fail together. This statement must move our database from one level of consistency to another level of consistency. This statement must not interfere with any other statement that is currently running, and this statement must make sure that the changes are durable even if an earthquake happens or even if a meltdown of the drive happens. The database must be recoverable to the second that it went offline. So we said that these four things must be possible if we have to run this particular statement. So let's go and run this statement and see what happens. All right, so we ran the statement, and at a point we encountered an error. Okay, we encountered an error. The error message is, we are told the error message, but that's not even where we are going. Let's look at the result, because part of this statement is a select from that table. So let's look at the result. The result, it shows that 1, the table was created. The first insert statement was completed, which is why you see 1 here. The value that we inserted into that table is 1. That's why you see 1. The second insert statement was attempted, but there happened to be a runtime error because there is a divide by 0. You can't divide any number by 0. There's a divide by 0, so there is an error. So the transaction threw an error. But look at what happened. Because it's an auto commit, what happened is we allowed the third statement to go on. So if we go back, we see that it inserted 3. So what it did was, for an auto commit, in an auto commit mode, whenever you encounter a runtime error, the behavior is the error statement is rolled back, but the rest of the batch still continues to run. Does that make sense to everybody? So the behavior when you run an auto commit is 1, the statement that causes the error is the one that is rolled back, but the other statements continue to execute. And that's why you were able to get this and this. Does anybody have a question about that? The reason for an auto commit is that each statement is treated as one transaction. Okay, so this statement is taken as one transaction, this statement is taken as another transaction, this statement is taken as another transaction, and this statement is taken as another transaction. And what happened is, this transaction happened, then it succeeded together, it was committed into the database table. This transaction happened, it failed together and was rolled back and nothing happened. Then this third transaction happened, it succeeded and it was committed. And then by the time we now run this statement, we see that only 1 and 3 was committed. Okay, so just note that in an auto commit mode, whenever you have a runtime error, the statement that causes the error is rolled back but the rest of the batch would continue to function and run to completion. All right, now let's go to an explicit transaction. All right, the only difference is if you want to run an implicit transaction, if you need to run an implicit transaction, all you just need to do is set implicit underscore transaction on. Okay, just like we have implicit underscore transaction on. All right, if you want to use an implicit transaction underscore transactions. Yes, when it wasn't turning blue, I knew there was an issue. All right, so set implicit underscore transaction on. Once you set this on, execute it, then this becomes anything you run in this session becomes an implicit transaction. Okay, first we looked at auto commit transactions, right? We looked at auto commit transaction. Auto commit transaction, you don't see the begin transaction. For an implicit transaction, once you set the flag, the session option, once you set it to on, right, you will run the statements as an implicit transaction. Okay, the only difference this has with an auto commit transaction is in an implicit transaction you have to either commit the transaction, so you have to specify a commit statement, or you have to specify a rollback statement. Okay, first let me drop this table so that we can use it again. All right, I'm going to set implicit transaction to off for the meantime. Okay, so it's back to off, which is the default. I want to drop this table so that we can use the implicit transaction to run this particular statement and see what the behavior is. Okay, so I'll copy this here and then I'll just change this to on. So, but first I want to drop the table. And you know why I'm dropping the table? The reason I'm dropping the table is you cannot create an object in SQL Server that has the same name. All right, object names has to be unique. If we had run this without dropping the table, what we would have done is we would have tried to create an object with the same name, and the database would tell us we can't do that. So I'm dropping the table, so things are back the way they should be. That table is gone. All right, so now create table. Right, don't write the way I'm writing. This is just a shortcut. All right, until you understand exactly what you're doing, just write a different drop statement. All right, so now we don't have that table anymore, but now instead of an auto commit transaction, we want to use an implicit transaction. All right, so execute. We are now in an implicit transaction. So let's run since we are already in the student database, let's run all these statements and see what happens. Okay, now we have what we expect to write, but let's check what transaction we have. Transaction at tran count. Okay, you will see that we have an open transaction. Okay, and then you would ask the question, but we did not start a transaction. However, remember we are in the implicit mode. That means that the begin transaction is unseen, but we have to either cancel the transaction by writing a rollback statement or complete the transaction successfully by writing a commit statement. All right, so in this case we had an error. All right, so we have an error going on. We don't want to commit errors into the database. All right, so let's just roll it back, which is where the implicit transaction is different from the auto commit. So let's issue a rollback transaction statement. Okay, rollback transaction, because the reason is we have an active transaction going on. Okay, if we come to another session and we try to select star from, is it T3, is it T1 or T2? I don't know what I named it. It's T3. Okay, T3. You can see that it's not giving us the data in that table. You can see that it just keeps spinning. The reason it keeps spinning is that we have an open transaction. Okay, and that open transaction is locking down that table. So if you look at this new session as another person trying to access this resources or this resource, then that person does not have access to that resource simply because you have an open transaction. All right, and that's why we are going to roll back that transaction. All right, so if we roll back that transaction, you would see that now if you select, it will tell you that there's an invalid object name. Why does it say that? Because the create table was part of the implicit transaction. When you rolled it back, when you rolled back the transaction, you cancelled everything that happened in the transaction, including the create statement. All right, this time let's commit that transaction. We are still in the implicit mode. Okay, we are still in the implicit mode. The only thing is we don't have an open transaction anymore. So let's select the tran count. Now we have a closed there is no active transaction. That's what I'm trying to say. There is no active transaction. So now, still in the implicit mode, let's create that table again. All right, we have the same error. Now let's select from that table and make sure that in this session that created, select star from T3. Okay, so before we do that, let's see if we have any active transaction. All right, we have an active transaction just because we were still in the implicit mode. Until you switch off the implicit mode, it will still keep being in the implicit mode because it's still one session. All right, so if we select from that table, we are expecting 2 rows, and we have 2 rows. But then remember, we still have an active transaction going on. So if we go to this session and we execute, you can see that it's not letting us access that table because this session has put a lock on that table. Remember the properties of a transaction, it has to be isolated. All right, and the reason is you don't want to be working on the data in this session and somebody else in another session can change or can access that data. All right, you don't know what they are going to do if they access the data. That is why there is that safeguard that you literally lock the resource from being used. Okay, so now this transaction that is still going on here, because we have checked the tran count to be 1, this transaction that is still going on here is holding that resource. Another session cannot view the data in that resource, which is our table. Okay, so at this point, let's commit the transaction. The first time we rolled it back. Now let's commit the transaction, commit transaction, and then run this statement. All right, so when we run this statement, you can see that now you can already see that it's retrieved the 2 rows that we were expecting. All right, the 2 rows were retrieved. All right, at this point, that particular operation has become a permanent part of the database. All right, so that the database has been taken from one level of consistency to another level of consistency, and now it is durable. All right, until you change that data or you delete it, nothing can happen to that data. All right, now remember, we are still in implicit mode, so because we don't want to continue to be in implicit mode, we just set implicit transaction to off. All right, and then now we are back in the default and we can continue what we're trying to do. Any question? So now let's talk about explicit transactions. Those are transactions that you start. You see there's a scene begin transaction. You are the one saying that I want to start a transaction, and you are telling the database that I'm going to explicitly start a transaction by issuing a begin transaction statement, and any statement that follows after it, I want you to take those statements as a transaction. I want them to follow all the properties of a transaction, the ACID properties. They must be atomic. They must be AC. That's what's C? I just lost thought of C now. They must atomicity. They must be consistent. They must be isolated and durable. All right. So just note that as long as you have that at the back of your mind, you would know how to explain or how to work with transaction. So you're telling the database engine that I want these properties to be enforced on all the statements that follow my begin transaction. All right, so let's look at an example and see what this is trying to achieve. All right, so the first thing is we are already in the student database, so that's fine. So you can see that we are setting the session option exact abort. We are turning it on. Normally it's off, but we are turning it on. So exact abort, like we said, they control the behavior of runtime errors. Okay, so since we know that exact abort controls the behavior of runtime errors, we want to roll back when an error occurs. We want to roll back that error. Okay, but remember, this is what happens when you issue an exact abort. Execution of the rest of the batch is cancelled. You have to juxtapose that with what happened when we did both auto commit and implicit. You will see that in auto commit and implicit, execution of the rest of the batch continued to occur because exact abort was set to 0, or exact abort was set to off. Sorry. So execution of that runtime error that happened here did not affect this from happening. Now let's see the behavior when we turn on exact abort. I just want you to focus on that statement. When exact abort is on and you have a runtime error, it will roll back the statement that causes the error, and it will stop any part of the remaining batch any remaining part of the batch from executing. Okay, so let's go see if this is what we have. So we set exact abort on. We are telling the database engine, make sure that whenever we have a runtime error, roll back the statement and stop the remaining part of the batch from happening. That's the command you just gave. All right, then you create a table. That's what we want to do. Same thing, but a different table. Now we are calling that table T5. Okay, so we create that table, and then we now begin our transaction. Do you understand? The first thing we do, we set exact abort on, then we create our table, then we begin our transaction. And look at what we did, begin tran. You can say begin transaction, or you can say begin tran. It's the same thing. All right, so we begin our transaction, and in the transaction we are inserting 4 rows. Remember, C is a primary key. That column is a primary key. All right, we are inserting into that column, but look at this, the second and the third, we are inserting the same value into a primary key field. So immediately we know that that's not going to happen, because the primary key constraint will be violated because of this duplicate. All right, but then we are saying that if everything works fine, we are issuing a commit transaction, and then we want to read from the data. All right, so let's go ahead and do this. Let's set exact abort on for that session. Let's create our table. The table is created. Let's read the data from the table. There's nothing in that table right now. All right, so let's now insert these 4 rows into the table using a transaction. We begin a transaction, and then we are committing the transaction. So everything inside here must all fail together, or they must succeed together. Remember, exact abort is on. All right, so let's go ahead and do this. Just like we know, violation of primary key, and this is the name, and the message is cannot insert duplicate key into T5. All right, it tells you what the duplicate value is 2, right? And we can see it right here. Okay, we can see it right here. So an error has occurred, exact abort is on, an error has occurred. Let's see what's inside the table now. Nothing. Why? Because whenever exact abort is on, any runtime error that occurs is the statement that causes the error is rolled back, but no part of the batch continues to execute. In that way, you have made sure that these particular statements that were all in a transaction follows the ACID property of transactions: atomicity, consistency, isolation, durability. Let's check the value of @tran count. Zero. There's no open transaction. Okay, so we started the transaction, inserted all the values. When it got to the row 3, it encountered an error. Exact abort kicked in, rolled back the statement. Once it rolled back the statement, @tran count was reset to 0. and exact abort made sure that this last statement did not execute. Is there any question? Any question? Is there any question? No question. All right. Now, yes. Now, if you look at this particular example, the reason we did this is, the reason we set exact abort on is, hold on please. Okay, so if you look at this example that we gave, right, we said we wanted all this to happen together. We don't want to insert one row and not insert the remaining 3 rows. We don't want to insert 2 rows and not insert the remaining 2 rows. We don't want to insert 3 rows and not insert the last row. We want all the 4 rows to be inserted together. Okay? So, at that moment, the programming construct that can help us do that is a transaction. Okay? So, without even thinking about anything, since we have that requirement, what we do is we start a begin transaction, and then we commit the transaction. Okay? So now we have this. That's what we have, because we are told to insert 4 rows that must happen together or must fail together. So we did we lose Tosin? So we have a requirement that we have to insert. Hold on. So if we look at this particular example, our business requirement was insert 4 rows into the newly created table. We want the 4 rows to be inserted together. We don't want to insert 1 row and not be able to insert the remaining 3. We don't want to insert 2 rows and not be able to insert the remaining 2. We don't want to insert 3 rows and not be able to insert the last row. We want all the 4 rows to be inserted together. When you hear a business statement like that, the first thing that comes to your mind is the programming construct that I can use to ensure that this is possible is a transaction. And then at that point, you just come and then you write your begin transaction, begin transaction, it doesn't matter. And then to end the transaction, you write a commit transaction. Okay, so now you have like the scaffold for making sure that everything in your business rule happen together or fail together. All right, now what we're saying is you now bring in your business rule. All right, you bring your business rule and then you put your business rule in the context of the transaction. So if you start this transaction, everything that happens under it would have to succeed together or fail together. That's the A in the ACID property of transaction. So regardless of what your business rule is, either complicated or simple, as long as it fits the requirement of happening together or failing together, you know you have to put them in the context of a transaction, and that's what you have done. Okay, so you can go ahead and do this, but then as a programmer you think to yourself, I can't just stop here. What happens if something fails? That's the question you ask yourself as a programmer. You might say, no, nothing is going to fail because I wrote it, but then you don't know what's going to happen when your program is being run. What if, although you wrote the best code, the most errorless code, if there's anything like that, what if there's a power outage during the time that your program is running? What would you do if 2 rows have been inserted and there is a power outage? What happens? All right, so that's why you would think to yourself, what if an error occurs? All right, so what do I do if an error occurs in my transaction? I want to roll back everything. So how do you ensure that this happens? Because the computer, since you have started a transaction, the computer will just hands off. Okay, the computer will tell you, because of your begin transaction, you have taken over control. I'm just going to stand on the side and look. So if you start a transaction and you don't tell the computer what happens when an error occurs, then the computer does not know what to do, because you were the one that took control from the computer when you issued your begin transaction. Okay, so at this point you have written the code when everything would go on fine. The point we are in writing the code is we are assuming everything will go on fine. But what if something happens? What if an error occurs? We have to handle that also. So what do? We just say set exact abort. Set exact abort on. Okay, so now we have a situation where we have handled if everything goes on correctly. With the exact abort, we have a situation where we handle if things go wrong. And that is how we come about this. All right, so regardless of the complexity of your program, as long as your line of thought or the way you are thinking about it is how I've explained it, then all you need to do is plug that business rule into your transaction block. Let's set exact abort off and put the session back in the default, in its default position. So this time, if an error occurs, because exact abort is off, then there is no rollback if we don't specify a rollback. Okay, now the reason why we don't encourage that you use exact abort to roll back your transaction is because you might forget. Exact abort's default is off. So there's a tendency for you to forget. So in that case, if you are going to want a way to deal with errors, just use your error handling methodology, the one you learned, the error handling syntax that you learned, which is begin, try, begin, the try catch block. Okay, now we're going to create a new table. This time I'm going to write it out because it seems like, because it's already written out, it might not be easy to follow. But in this case, I'm going to use a try catch block to do exactly the same thing that we did with exact abort. Okay, the reason we use exact abort was we wanted to deal with the errors. Okay, so since we wanted to deal with the errors, there's an error handling format that we've already learned. Why don't we just use that? All right, so let's create another table, the same type of table. Let's create another table. Now exact abort is set to off, so we are in the default position. Let's create another table and call it C6. We could as well drop the last table and do the same thing, but let's create another table. Let's call it C6, all right, T6, and then the same column, which is a primary key. So let's create the table. The table is created. Now let's use a try catch block. So begin try, end try, begin catch, end catch. Okay, so we have our try catch block. Now we are going to put every statement that can cause an error in the try block, all right, but we want them to succeed together or fail together, all right. So because of that, please hold on 1 second. The point we have right now is we have a scaffold to deal with errors. Okay, we have this scaffold to deal with errors. Begin the try catch block. Okay, so now we're going to put all the statements that can cause an error, we're going to put them in the try block. But remember, we want them to succeed together or to fail together. So what do? In the try block, we start a transaction, an explicit transaction. Begin tran, and we assume that it's going to succeed, so we commit the transaction. All right. Now, inside the context of the transaction is where we will put all our logic that we need to fail together or succeed together, which is the insert statement that we saw earlier on, right? The same 4 rows. We want those 4 rows to succeed together or fail together. All right, so at this point we have written the code for the situation where everything works fine. The code is written to perfection. We have assumed that nothing can go wrong, but something will go wrong. We should always anticipate that any code is error prone, right? No matter how fantastically written it is. So since at this point we have dealt with the non-error part, let's think about the error part. All right, something might happen. Okay, so if something happens, if an error occurs, where do we code our error handling logic? In the catch block. All right, so we have to come to the catch block, and when an error occurs, what do we want to happen? We want to cancel the whole transaction. If an error occurs, we don't want anything to succeed. All right, so in our catch block, we just put a rollback transaction. So now we are in control. Once we issued a transaction statement, a begin transaction, we are going to be the one that will control everything that will happen in that program, right? The first thing is we have controlled the part where if everything works fine, go ahead and complete the logic successfully and make it a permanent part of the database. All right, then if something goes wrong, go ahead and roll it back, because if an error occurs in the try block, any error whatsoever that occurs in the try block, guess what? It jumps into the catch block. So if an error occurs anywhere here, then it will jump into the catch block, and what's inside the catch block? A rollback transaction. Okay, so you can see how you are able to write your explicit transaction, making sure that you look at if everything succeeds, and then you look at if something happens that would stop your code from succeeding. All right, you can, before rolling back, you can print out anything, or you can log anything you need to log. You might want to log, you might want, in fact, let's, instead of printing something out, let's still print it out. Or let's select it. Select. Remember the functions, error underscore message. Remember all the catch block functions. You can use any of them here. So again, everything we have been learning so far, we are learning in a way so that we can be able to use it to start writing procedural programs. All right, so you can use any of the catch block error functions. You can use any one you like. You can print anything, but in this stage I'm not printing anything out. I'm just going to read the error message, and then once I read the error message, I'm going to roll back the whole transaction if an error occurs. And remember, we are anticipating a violation of the primary key because we are trying to insert a duplicate. So let's go ahead and try this statement and see if it works. Now, you can see that this error message is handled gracefully. Is not screaming out to you the way the error message with the exact abort was screaming out in all red. Alright, this is handled gracefully, is returning this error to you using the error message. Remember, we are selecting the error message function. So it's displaying this message that this is the error that occurred. Alright, let's look at the message part. Okay, now it says all these rows are affected, but let's go and select from the table and see if indeed we have any data inserted. And you can see that we don't have any data inserted because what happened was, by the time we ran this statement, it's errored out on line 3 or on the third row. It errored out because that's a duplicate. So these first two had already been inserted. At this point, an error occurred. When the error occurred, the program jumped into the catch block because this is in the context of a try block. The program jumped into the catch block, and what does it see in the catch block? It saw that select the error message. It did that for us, and then again it rolled back the whole operation. So all these two that were already inserted, it rolled it back, and it did not allow this to happen. Okay, so that's why when we run it, you see that we get the error message from the function, and if we execute and read from the table, you would see that there is no row in the table because everything was rolled back based on that error. And if we also select to see if we have an active transaction, you would see that there is no active transaction because when the rollback transaction occurred, it ended the open transaction. Okay? Question? So, a transaction can have a name. It's not required, but you can decide to give your transaction a name. If you want to give it a name, you can either name the transaction using a literal value, like let's say begin transaction, my transaction. Okay, you can give your transaction a name, right? Or you can put the name in a variable and pass it to your transaction, just like what we have here, right? So you declare a variable, call it whatever you want to call it. At this point, we are calling it tran name, right? And then give it a character data type. Now initialize the tran name variable that you just created as the name you want to give your variable, or the name you want to give your transaction, and just pass that variable to your transaction. Okay, so you can name a transaction, and when you are committing or rolling back that transaction, you can also use that name for that transaction. Again, it's not required, but just know that it's available for you to use. So for this, we want to delete from job candidate the candidate ID 13. That's what we want to delete. We want to delete from the job candidate table the job candidate ID 13. So as we always say, let's read the data before we manipulate it. All right, so let's select star from this particular table, all right, where the job candidate is 13. So let's look at what we are trying to delete. All right, we want to delete this row. Okay, we want to delete this row from this job candidate table. So we are going to declare, it's going to be a named transaction. So we will declare this transaction. Okay, and I'm going to run this up to the where. I'm not going to commit it yet. Okay, so let me run it up to here, and we see that one row affected, but because I did not commit or roll back, at this point, if we check the value of at tran count, what do you think the value is going to be? What do you think the value of at tran count is going to be at this point? Any takers? We started a transaction, we neither committed it nor rolled it back. What would the value of at tran count be? Okay, you are the programmer. You are not going to assume that things are going to be done for you. You are the one that will dictate every step that your program has to take. In our example, we started a transaction by issuing a begin transaction, but we did not commit it or we did not roll it back. That means that we have an active transaction. And whenever we have an active transaction, tran count is incremented by 1. Because we had just one begin transaction statement, then tran count at this point will be 1. And when we checked it, we see that is 1. But then let's read the data from the table again. You can see that now we've deleted that data, but that data is not part of the database yet, because we have not committed that change. Okay, we have not committed that change, so that means that our database table is still in a state of inconsistency, because we have not committed what the data manipulation that we just did. And to prove that, let's roll it back at this point. Let's not commit it. Let's roll back that transaction. Actually, you can just write roll back. You don't need to put a transaction. You can just write roll back. All right, so roll back. Now let's check the value of at tran count. At this point, what would the value of at tran count be? 0. Good. So at tran count is 0. Now let's check the operation that we did. Remember, before we rolled it back, it wasn't in the database anymore, although it's in an inconsistent state. Any time you have an open transaction or an active transaction, or when @trans count is not 0, is greater than 0, that means that that particular object is in a state of inconsistency. It's neither in the database nor is it cancelled. All right, but now we've rolled it back. @trans count is now 0. Let's see what we have for our manipulation. You can see that you now have it, back, because what we did was we rolled it back. We did not commit it. We cancelled anything that was happening in that transaction, and that's why you still have it. All right, I'm going to demonstrate it again. We will start the transaction with the name. We will delete the data, but we won't commit or roll it back. All right, so we have done that, and then we check that transaction. We check our database row, the one that we are trying to delete. We see that it's been deleted, but we are in an active transaction. That means that our database is inconsistent, right? We are in an active transaction. So this particular change is not persisted yet. It's not a permanent part of our database yet, because if we issue a rollback, we are still going to get that deleted data. We are going to get it back, just like now. All right, so now we want to delete and commit that transaction. That means make that change part of the database. What's the change? We are deleting the data. All right, but we want to make sure that change makes a permanent part of our database. So if we start the transaction, we check @trans count, it's 1. We have deleted our data because it's no longer there, but now let's commit the data. Instead of rolling it back, let's just commit that data, or let's commit the change. All right, now that it's committed, if we check, we will see that the change has now become a permanent part of our database, because we not only do we not have an open transaction, but we don't see that row anymore. Okay, if we now say for any reason we want to roll it back at the state where it's been committed, where it has become a permanent part of our database, guess what is going to happen? The rollback transaction request has no corresponding begin transaction. Okay, so before you can roll anything back, it must be in an active transaction. Okay, so just note that. Any question? Any question? It says the following statement starts a named transaction. All right, remember what a named transaction is. The transaction has a name. It inserts 2 rows and then rolls back the transaction named in the variable @transaction name. Right? Another statement outside the named transaction inserts 2 rows. The query returns the result of the previous statement. Okay? Now, what this is saying is, we're going to use tempdb, by the way, because we want everything to go away once we are done. All right, so we're going to use tempdb. We create a table. Let's create a table. It's called value table, and it only has 1 column called value. It's an integer. So let's create that table. So we've created value table. Let's select and see what's in that table. There's nothing in the table right now because we just created it. So what we are saying is we are starting a named transaction here. We are saying we are starting a transaction. The transaction is named with the variable @transaction name. that means that it's transaction 1. Okay, so we have a named transaction. Now in the transaction, what we are doing is we are inserting 2 rows into our newly created table, and then we are rolling back the transaction. Okay, then once we roll back that transaction, we are now, after that, we are now inserting 2 more rows into that same table. The first rows that we are in, the first 2 rows are 1 and 2. We are rolling them back, and then we are now inserting 3 and 4. What would you think will be in the value table when we complete this transaction? So let me explain it again. We are starting a transaction. We are inserting 2 rows into a table. We are rolling back that action, and then we are now inserting 2 more rows. Now, when we run the select from the table after our operation, what rows do you think will be in our value table? Think about this. Think about this. This is just to test your knowledge about everything we have talked about. Think about this. We are starting a named transaction. We start the transaction, we insert 1 and 2 into the table. Row 1, row 2, we have the value 1, 2. And immediately, we are rolling back that transaction that we just started. At this point, what's going to be in value table? Nothing. Yeah, nothing. All right. So nothing is in transaction table. At this point that we are right now, what is the value of @tran count? 0. Good. So now, after that, we now insert 3 and 4 into value table. Now, by the time we now select value from value table, what will be in value table? 3 and 4. All right, let's see if this works the way we have narrated the whole scenario. All right, the first 2 rows are your 2 rows here. They were rolled back, and then you now inserted 2 more rows. Now let's select and see if that's what we get. You can see 3 and 4. Okay, so that just goes to tell you that if you begin a transaction, @tran count becomes 1 if it was 0 before. Now that will continue until it either sees a commit transaction, at which point @tran count becomes 0 and the change becomes part of the database successfully, or it can encounter a rollback, at which point @tran count is also becomes 0 and it cancels that operation. Question: